Today we will draw a graph of the sine function, and we can suppose our angle x is between 0 and 360 degrees. And recently we learned how to convert degrees into radians. So I will ask you guys to draw a careful and precise graph, as precise as you can, of the sine function. But right now x will be in radians, so our angle is in radians, and y is the value that our sine function attains. So why don't you give it a try? If you are stuck a little bit on how to start, we can start with the values that we know. We'll learn some special angles. So for example, sine of angle 0 with 0 degrees is the same as sine of 0 in radians, and we should know this value. The same thing about 30 degrees, which is sine of pi over 6. We should remember this value. Next special angle, sine 45, which is sine of pi over 4. Sine 60, sine pi over 3. And sine of 90 degrees, which is sine of pi over 2. You all guys should know these values, and then to continue your graph, you should think about unit circle, right? Because when we move along the unit circle with angle theta, our values of cosine theta and sine theta change. And you can start plotting the graph for values of theta bigger than 90 degrees. And I suggest you to take another graph and graph it again. So see if you get a better, a more precise looking graph right now. So if you forgot, the value of sine 0 is equal to 0. The value of sine 30 degrees and sine of 60 degrees we can find from the right triangle, say of side length 2. It's going to be the opposite side 1 divided by hypotenuse. So sine 30 is 1/2, sine 60 is root 3 over 2. The value of sine 45 degrees is 1 over root 2. If we consider a right triangle, isosceles triangle with degrees 45, 45, 90, and sine of 90 degrees is 1. So we will start plotting. If we start plotting, we should be very careful, because I can take 2 pi first, I divide it in half, this is my pi. That will be my pi over 2, I again split into halves, 3 pi over 2. Then I split again in half, will be pi over 4. If this is pi, and we know pi is 3.14, 159, and so on, so our 1, our unit, will be approximately 1/3 of the pi, a little bit less. So we can graph it over here. This is 1, and this will be our negative 1. So if this is 1, let's plot. At 0 we have 0. At pi over 6 we have 1/2. At pi over 4 we have 1 over 2, which is slightly bigger. This is how our graph looks like. And then we know that we can continue, because if we go along the unit circle, the value of sine of x, if we have angle theta here, which means the big angle will be 180 minus theta. So sine of 180 minus theta is the same as value of sine theta. And in our case, it's pi minus theta. So the graph will be symmetric once I go from 0 pi over 2 to pi over 2 to pi. So again, we plot our points very carefully with symmetry. and we should get something like that. And then we move on, and we get to here. Okay? So one thing I would like you to pay attention that the sine curve, it's not a sequence of semicircles. This is a favorite graph of students. Well, it is not, because again, 1 and pi, you can see the curve is stretched out. So it looks like that, and we can continue it because sine, as we already studied, it repeats itself after we move after 360 degrees. So finally, before we end this exercise, I would like for you, in your best graph, draw the line y is equal to x. And then, if you draw it well, you think how the line y is equal to x is related to the graph of the y is equal to sine x. And to think about it, we can again take a unit circle, think what happens when you travel angle x, and think of what is the meaning of x in our case, and what happens in this region when x is very close to 0. Well, if you draw your line well, y is equal to x, it actually should not intersect your graph. Why is that the case? Because, look, if we travel angle x, the meaning of x, the meaning of our x-axis, this is the arc we travel along the unit circle, right? That's why it is more convenient to use radians rather than degrees, because they have a meaning in our case. And what's sine x? Sine x is just the altitude at each point, at the point after we travel the distance x along the arc, right? So sine x represents our altitude at every step if we travel along the circle x, angle x in radians. So from here, what you can say about x and sine x? Well, you can see that sine x is always less than x, right? And this will be important in the future, and this is why our line y is equal to x should not intersect the graph of the sine function.